एनालिसिस में फर्स्ट ग्रुप हम पढ़ चुके हैं। फर्स्ट ग्रुप के जो रेडिकल अगर आप याद रखें तो फर्स्ट ग्रुप में 3 रेडिकल थे, Ag प्लस, Pb प्लस 2 और Hg 2 प्लस 2। और फर्स्ट ग्रुप में इन रेडिकल्स को प्रेसिपिटेट आउट करवाने के लिए वी हैव पुट डाइल्यूट HCl सॉल्यूशन सो दैट क्लोराइड्स आर प्रेसिपिटेटेड आउट। अब जो फर्स्ट ग्रुप का फिल्ट्रेट है, like what is the method कि after reaction of after testing of a particular group the remaining portion is again tested for another groups. Like if first group filtrate we are taken after precipitated out, so first group filtrate is testing for second group, so this process is in continuation. Second group contains 2 type of radicals, one is second A and another is second B. In second A, there are 5 radicals, Ag plus, Hg plus 2, Pb plus 2, Bi plus 3 and copper plus 2. The question is that, why we are testing again Pb plus 2? The reason is that Pb plus 2 is again tested as PbCl2 is soluble in hot water. And it may be undetected. What is meaning of this? Like when we were testing of first group, and in the first group we have added HCl solution, dilute HCl solution, and PbCl2 is formed. Now if test tube is hot, then what will happen? This PbCl2 is soluble in hot water and it will not come in the form of precipitate. So it might happen that in the first group test Pb plus 2 is not detected, and if Pb plus 2 is not detected, we are again testing this in the second group. So first A, he has 5 radicals, Ag plus, Hg plus 2, Pb plus 2, Bi plus 3, Cu plus 2. Another group is second B. It has 4 radicals, Sn plus 2, Sn plus 4, H plus 3 and Sb plus 3. Now, what is the difference between second A and second B? That second A, all these radicals are insoluble in YAS and second B are soluble in YAS. What is meant by YAS? It is yellow ammonium sulfide and formula is NH4 whole twice SX. X may be 1, 2, 3, 4 integer. So second group has been divided into 2 subgroups. It is insoluble in yellow ammonium sulfide. It is soluble in yellow ammonium sulfide. Insoluble and soluble. This is having 4 radicals. This is having 5 radicals. Now we are coming on the next thing. In the first group filtrate, we will pass H2S gas in presence of HCl. Like HCl already in first group testing, we have put a dilute HCl solution. So if first group testing is done, now we will pass H2S gas in the solution. And second group cation will precipitate out if it is present. Now point is that in acidic medium H2S gas is passed. If acidic medium is present, like HCl was already present in the solution and it gives H plus and Cl minus ion. When we will pass H2S gas, it will give H plus ions along with S minus 2 ions. Now already H plus ions are present as a common ion. So due to common ion effect, this reaction goes in backward direction. Or we may say that the less ionization will take place. And what will happen with less ionization? That lesser number of S minus 2 will formed. So what will happen? Ki only second group is precipitated out here as their Ksp is low. Now we will see later that fourth group radicals are also precipitated out in the form of sulfides, but their Ksp is high, so they require more number of S minus 2 ions. So if in this solution HCl would not be present, what will happen? that the more number of S minus 2 ions will be in the solution, and fourth group radicals, which we will test later in later part, will be precipitated at the time when we are testing for second group. What I am saying, that we are testing for second group radicals and they are precipitated out in the form of sulfides. If HCl would not be present, then fourth group radical will precipitate here along with second group, because they require more number of S minus 2 ions. Now we want that fourth group radical should not precipitate out here. So we are putting acidic medium. So lesser number of S minus 2 ions are produced, and only those sulfides are precipitated out here which are having lower value of KSV. So first point is that H2S gas is passed in the presence of HCl gas. Now we have passed H2S gas for the precipitation of second group radicals. And in case of second group radicals, the precipitation is in the form of sulfides. So out of 5 radicals, 4 will form black sulfides. So black sulfide are formed by Hg plus 2, Pb plus 2, Bi plus 3 and Cu plus 2. While fifth one, Cd plus 2 will form yellow sulfide. It has to be remembered. In the second B group, Sn plus 4 forms yellow PPT, H plus 3 forms yellow PPT. While Sn plus 2 forms brown PPT and Sb antimony forms orange PPT. Now the question was J advanced last year was from this. It was asked that identify the yellow color, black color sulfides, black or brown color sulfides. So out of these sulfides it was asked how many are the black. Now we have passed H2S gas in presence of HCl. We cannot use H2SO4 in place of HCl, because if H2SO4 is used, it will produce SO4 minus 2 ions, and these SO4 minus 2 ion will precipitate Ba plus 2, Sr plus 2 and Ca plus 2 in the form of sulfates. Their sulfates are insoluble in water. So what will happen, that fifth group radical will precipitate out here in the form of sulfate if we have been used H2SO4 solution. So it should be avoided. For making acidic medium, we even cannot use HNO3 solution, because HNO3 is a strong oxidizing agent, and what will it does? The HNO3 oxidizing agent will oxidize S minus 2 into sulfur, and the solution of sulfur is yellow colored and colloidal solution is formed. So what is the problem if yellow colloidal solution is formed? That it creates confusion with CDS yellow and S2S3 yellow. Now we are identifying CD plus 2 if black yellow PPT is formed in the solution, and we have placed HNO3 for acidic medium, then H2S gas is passed and S minus 2 ion, sulfide ion, forms yellow solution. So we can think that CD plus 2 was present even though it was absent. So we want to avoid the oxidation of S minus 2 solution, so that yellow solution is not formed. It must be formed only when CD plus 2 is present or S plus 3 is present. Starting a mapping for these second A group radicals. First group filtrate, which is remaining after testing first group, will pass H2S gas in presence of HCl gas, HCl solution. So we have understood that why HCl is required to provide acidic medium. Now precipitate is formed. If precipitate is insoluble in YAS, then it must be second A group radical, and it is precipitated in form of sulfides. We have seen the color of sulfides of second A group. Now what we will do, that we will dissolve these sulfides in 50% HNO3 solution. Out of these 5 sulfides, HGS is insoluble. So what we can say, that if second A group precipitate is insoluble in HNO3, it might be Hg plus 2. Gs is since insoluble in dilute in concentrated HNO3 solution, we will put aqua regia. Aqua regia is 3:1 ratio HCl and HNO3. So insoluble sulfite of Hg plus 2 will be soluble in aqua regia, and in aqua regia it will give Hg precipitate in the form of black. ठीक, HGS जो है वो after soluble what we will do कि it is soluble, Hg plus 2 is soluble, we will put SnCl2, and as SnCl2 is a reducing agent, it will reduce mercury Hg plus 2 into mercury black. Okay. So insoluble HGS is soluble in aqua regia. In aqua regia Hg plus 2 ion is present, and Hg plus 2 ion we will put a reducing agent SnCl2, which will reduce Hg plus 2 into mercury, and mercury is black color. So insoluble sulfide is separately tested. Now remaining 4 sulfide of second A group are black in color, and these black colored, this is also black colored sulfide. Remaining 4 are, 3 are black and 1 is yellow, CDS. So second A group, in second A group sulfide is added in 50% HNO3. If it is soluble, then there are chances of 4 group radicals. The remaining 4 group radicals are copper plus 2, Pb plus 2, Bi plus 3 and Cd plus 2. What we will do? We will put dilute HCl. We will add dilute HCl solution. Dilute ion, and this sulfate ion will go with Pb plus 2 ions, and it forms PbSO4 white PPT. So after addition of dilute H2SO4, if white PPT is formed, it may be PbSO4. Now what we will do, that we will dissolve PbSO4 in ammonium acetate. After dissolving, the solution is prepared, which is having Pb plus 2 ion. In this solution, if we add Ki solution, then I minus will go with Pb plus 2, forming PbI2 precipitate, which is yellow in color. So out of these 4, Pb plus 2 is separated by the help of dilute H2SO4. Now the remaining solution has these 3 radicals. So remaining solution is having copper plus 2, Bi plus 3 and Cd plus 2. What we will do? We will put NH4OH solution. NH4OH solution, this OH minus will react with Bi plus 3, forming BiOH3 white PPT. So these 2 are soluble in NH4 plus solution, ammonium solution, and this gives precipitate with OH minus ions. So white PPT of bismuth is formed. We will add dilute HCl. In dilute HCl it is soluble, forming a Bi plus 3 solution, and if we put reducing agent Na2SNO2, this is called as sodium stennate. Sodium stennite. So in sodium stennite, what will happen? That Bi plus 3 is reduced into bismuth, which is black in color. So this is the testing of bismuth radical. After addition of NH4OH, if solution is formed, and how this solution is formed, that copper plus 2 forms complex with ammonium ion, Cd plus 2 forms complex with ammonium ion, and the complex is CuNH34 plus 2 or CdNH34 plus 2. If solution is blue color, then it may be copper, and if solution is colorless, it may be of the complex of cadmium. So by seeing the color of solution, if it is a blue solution, we will put acetic acid among with potassium ferrocyanide, and it forms brown PPT of Cu2 FeCN6. Means Copper plus 2 forms a complex with copper plus 2 means these copper plus 2 4 ion and this anion is having -4 charge. So brown PPT with potassium ferrocyanide. So it is confirmed as copper. And if colorless solution is formed, it may be cadmium complex, and in this solution if we pass H2S gas, it is unstable complex, so it readily gives CDS PPT again, which is yellow in color. Okay. So in this map we have separated all 5 sulfides, second A sulfides. So second A group sulfides are precipitated if we have passed H2S gas, in which out of this one sulfide is insoluble HGS and others are soluble. So it is separated, insoluble separated and add K aqua regia. In soluble solution first add dilute H2SO4, PbSO4 is precipitated out, it is separated. Remaining solution having 3 radical, NH4OH, this forms PPT with OH minus ion, and remaining 2 are soluble in the form of complex, and blue solution is of copper and clear solution of cadmium. So in this solution pass H2S, CDS obtained. In this solution add potassium permanganate, so ferrocyanide, brown precipitate is formed. So in the second A group, we are testing first for Hg plus 2 ion. If in Hg plus 2 ion, if we pass H2S gas, it will precipitate out in the form of HgS sulfide, which is black in color. It is insoluble in HNO3 50%, but it is soluble in 3:1 mixture of these 2 acid, which is called as aqua regia. HgS is soluble in this solution and it forms HgCl2 solute. So Hg is present in plus 2 ion form. If we put SnCl2, it is reducing agent. So first it will reduce Hg plus 2 into Hg2Cl2, and if we put SnCl2 in excess, finally it converts from Hg plus 2 to 0 state and Hg mercury of black PPT is formed. This is the main test of Hg plus 2. Another test, Hg plus 2 I minus means Ki is added. So I minus goes with Hg plus 2 and red PPT of HgI2 is formed. This red PPT is soluble in excess of Ki, forming a colorless solution of HgI4 minus 2. Next reaction, if we add copper in Hg plus 2, then redox reaction will take place. Copper converts into copper plus 2 and mercury goes into black mercury ion. So Hg plus 2, mercuric ion is forming mercury black. If we put NaOH solution in Hg plus 2, yellow PPT of HgO is formed. If we put cobalt plus 2 and HCN minus, it forms deep blue precipitate of COHG, HCN whole 4. So these are the main 4 tests for Hg plus 2 ion. Now the next radical is copper plus 2. Second A group radical we are studying. Copper plus 2, in copper plus 2 solution, if we pass H2S gas, CuS black PPT is formed. When we are adding concentrated HNO3 solution, it will be soluble in HNO3 solution, forming copper nitrate means copper plus 2 aqueous solution, which is blue in color. In this blue solution, if we add ammonia aqueous, or I may say NH4OH solution, this copper plus 2 will form a complex with ammonia, and the complex is CuNH3 4 plus 2 aqueous solution, and this solution is deep blue in color. Okay. It means copper plus 2 forms a complex with ammonia solution. In copper plus 2 solution, if we add I minus or I may say Ki solution, then I minus will react with copper plus 2 to forming Cu2I2. The redox reaction will take place. Means copper plus 2 and I minus, it will form Cu2I2 plus I2 is formed. Yani copper plus 2 is oxidized into copper plus 1, is reduced into copper plus 1, and I minus is oxidized into I2 gas. Means I2 gas is liberated, which is soluble in I minus solution, forming a I3 minus complex. I3 minus ion gives a Iodometric titration with hypo solution. Hypo compound is Na2S2O3, sodium thiosulfate. So I2 minus can be titrated against hypo solution, and the end product is Na2S4O6 along with I minus ion. So this reaction is used in iodometric titration. Okay. So copper plus 2 is reduced by I minus. This is a very good reducing agent, forming copper in plus 1 state, and I2 is liberated. I2 is titrated with hypo solution. In copper plus 2 solution, if we add NaOH, OH minus will go with it, and blue color precipitate CuOH2 is formed. If it is heated, it forms CuO, which is red precipitate. In copper plus 2 solution, if we add potassium ferrocyanide, then 4K plus ion are removed, and copper plus 2 forms a complex Cu2FeCN whole 6, and this precipitate is brown in color. In copper plus 2 solution, if KCN is added, Cn minus goes with Cu plus 2, forming a yellow PPT of CuCN whole twice, and it will, after heating, it decomposes into CuCN and Cn whole twice. Cyanogen gas is liberated, which is poisonous. So CuCN2, copper in plus 2 state, it has been changed into plus 1 state, and this CuCN is precipitate is white in color. If we add Cn minus in the excess amount, this goes into a complex CuCN whole 4 minus 3, and this complex is stable. Why it is stable? If we pass H2S gas, no precipitate is formed. In case of cadmium, we have seen that in cadmium complex, if we pass H2S gas, CDS is precipitated out. But in copper complex, if we pass H2S gas, no precipitate is formed. So and another reaction is, in copper plus 2 solution, if we add SCN minus thiocyanide combined with copper plus 2, forming a black PPT of CuSCN whole twice, it is unstable, slowly decomposes into CuSCN, which is precipitate and white colored, and along with SCN whole twice is formed. So these two reactions are almost similar, but the difference is yellow color PPT, here it is black PPT, and the disproportion is same. CuCN is white while CuSCN is white, and Cn whole twice is formed. Similarly, SCN whole twice is formed. का जो group है Bi plus 3 bismuth. So when H2S gas is passed, so S minus 2 combine with this, and Bi2S3 black PPT is formed. This black PPT is soluble in both dilute HCl and dilute HNO3. If we add dilute HCl, it will form BiCl3 aqueous solution. When this precipitate, black precipitate, is dissolved in HNO3 acid, it forms nitrate, BiNO3 whole thrice, aqueous solution is formed. And this aqueous solution, if we add NaOH, so OH minus will combine with, we can write Bi plus 3 also. So Bi plus 3 combined with OH minus to form white PPT of BiOH3. Now, if this white PPT is heated, it forms yellow-white PPT of BiO.OH, or if we add reducing agent Na2SNO2, so it can reduce this bismuth from plus 3 to 0 state, and black PPT of bismuth is formed. So what is confirmatory test? Bismuth plus H2S, black PPT is dissolved in HNO3, and when NaOH is formed, which forms black PPT of bismuth with Na2SNO2. Another test is, when in Bi plus 3 solution Cl minus is added, it forms BiOCl white PPT, which is named as bismuth oxychloride. If we add Ki solution or I minus solution, Bi plus 3 forms BiI3 black PPT, which is dissolved in excess Ki solution, forming soluble orange complex, and the complex is BiI4 minus. So this is another confirmatory test for bismuth. I minus is added, black PPT of BiI3 soluble in Ki, and soluble orange complex is formed. Now next second A group radical is CD plus 2. In CD plus 2 solution, H2S gas is passed, yellow PPT of CDS is obtained. This yellow PPT of CDS is dissolved in HNO3 solution, forming a solution containing CD plus 2 ion. In this solution, if we add ammonia or NH4OH solution, OH minus will combine with CD plus 2, forming a white PPT of CdOH2. Now this white PPT can dissolve in ammonia solution, forming a complex, soluble complex CdNH3O4 plus 2 aqueous, and it is colorless. So this is main testing for CD plus 2 ion. In CD plus 2 ion, if we add NaOH, white PPT of CdOH2 is obtained. Another test, in CD plus 2 solution, if we add KCN solution, Cn minus will combine with CdCN2, forming white PPT. Now this white PPT can dissolve in KCN axis, an unstable complex CdCN4 minus 2. And since this complex is unstable, if we pass H2S gas, again yellow PPT of CDS is obtained. In CD plus 2, Cn minus added, CdCN2 white PPT, axis KCN, unstable complex is formed, which gives yellow PPT after passing over H2S. Next test is for second A group radical Pb plus 2. In solution of Pb plus 2, if we pass H2S gas, black PPT of PbS is obtained. Now this black PPT is soluble in HNO3 solution, forming a aqueous solution of Pb plus 2 ions. In the Pb plus 2 aqueous solution, if we add H2SO4, SO4 minus 2 combines with it, and white PPT of PbSO4 is obtained. This white PPT can dissolve in ammonium acetate, forming again a solution containing Pb plus 2. In this solution, if we add Ki, I minus will combine with it, and PbI2 yellow PPT is formed. Or either, in this solution we add K2CrO4, potassium chromate. So chromate ion will combine with Pb plus 2, forming yellow PPT of PbCrO4. So in Pb plus 2, H2S gas is passed, black PPT is formed, which is soluble in HNO3. After forming soluble solution, H2SO4 is added, again white PPT dissolved in ammonium acetate, and in this solution, if we add Ki or K2CrO4, yellow PPT is formed. Next group is third group. So third group radicals are 3, L plus 3, Cr plus 3, A plus 3. After testing of second group, in second group filtrate, we will add NH4OH, NH4Cl followed by NH4OH. The sequence is first NH4Cl is added, then NH4OH is added. We will see the logic behind it. So OH minus ion are produced by NH4OH, and these OH minus ion will combine with these following insoluble hydroxides. So third group radical will precipitate in the form of hydroxides. Aluminium will precipitate in the form of hydroxide, and white color precipitate is formed. Iron forms red-brown precipitate, and chromium forms green precipitate. Some precautions is done. In second group filtrate, initially we will heat this solution. It is boiled off so that all H2S is removed. Otherwise, what will happen? That H2S will combine, H plus ion produced from this will produce more OH minus ions. And why we want less OH minus ion? Because these two precipitate are soluble in excess of OH minus ion. So first precaution, we have to boil off the solution so that all H2S is removed off. Now in the later part, we will add 1-2 drop of concentrated HNO3. Concentrated HNO3 is oxidizing agent, and concentrated HNO3 can oxidize iron plus 2 into iron plus 3. In our syllabus, we study only Fe plus 3. So if Fe plus 2 is present, we will test in the form of Fe plus 3 only. तो Fe plus 2 अपने सिलेबस में नहीं है, अपन Fe plus टेस्टिंग करेंगे इसकी सहायता से, ठीक है. तो we will report Fe plus 2 in the form of Fe plus 3. So all Fe plus 2 is converted into Fe plus 3. Now NH4Cl is followed by NH4OH. It is added first. So what will do NH4Cl? It will produce NH4 plus ions. NH4 plus ion will work as a common ion, and this common ion will reduce ionization of NH4OH. So less number of OH minus ions will be produced because reaction goes into backward direction. So in presence of common ion, degree of ionization of weak acid or weak base decreases. This is the concept. Now suppose we have added NH4OH and then we add NH4Cl. So common ion effect is not observed because OH minus will readily combine with these third group radicals. So our purpose to reduce OH minus ion concentration, so first NH4Cl is added, not after the NH4OH. Otherwise OH minus will combine and a common ion effect is not shown. Now we have added NH4Cl so that less number of OH minus ions are produced, and the purpose is that only third group radicals are precipitated. We don't want other group to precipitate here, so less number of OH minus ions are added. Otherwise 6th group can also precipitate here in the form of MgOH whole twice. Now the important precaution, instead of NH4OH we cannot add NaOH. Why we cannot add NaOH? Because NaOH is a strong base and this can dissociate 100%, forming more number of OH minus ion produced. What will happen? The precipitate of aluminium and chromium hydroxide it is readily soluble in NaOH. So we will not get precipitate of aluminium and chromium in the form of hydroxide. If we want aluminium and chromium to precipitate in the form of hydroxide, we want less number of OH minus ion which are produced by NH4OH, which is weak base. And before weak base we have added common ion, so it is very less ionized. So because of less number of OH minus ions, only this precipitate is formed. If we have used NaOH instead of NH4OH, then because of more number of OH minus ions, these precipitate will soluble in NaOH and it will not be reported during the testing. अगर एल्यूमिनियम हुआ उसमें और NaOH हमने डाल दिया तो वो प्रेसिपिटेट बनने की बजाय उसी में सॉल्युबल रहेगा, इसका मतलब हमें वो डिटेक्ट नहीं होगा, तो हम NaOH को यूज नहीं कर सकते. So excess of NH4OH, excess of NH4Cl is avoided, otherwise manganese will precipitate in the form of MnO2. In place of NH4Cl, we cannot use NH4 whole twice SO4. Sulfate cannot be used, ammonium sulfate, in place of NH4Cl, because it will produce SO4 minus 2 ions and it can form white precipitate with Ba plus 2, which is 5th group radical. So if we use ammonium sulfate, then sulfate can precipitate 5th group radical here. So to avoid this interference, we are avoiding NH4-2SO4. Now similar to NH4-2SO4, we cannot use NH4NO3 in place of NH4Cl, because if we use NH4NO3, it will produce NO3 minus ion and it is a oxidizing agent. So what is role of oxidizing agent? It will oxidize 4th group radical Mn plus 2 into Mn plus 3 ion, and since OH minus ions are present in the solution, this Mn plus 3 forms precipitate with OH minus ions. So these precautions should be done before testing of third group radical. So in the summary is that third group radicals are 3, Al plus 3, Fe plus 3 and Cr plus 3. Aluminium forms white PPT, Cr forms green and Fe form red brown precipitate. and the group reagent is NH4OH and it forms hydroxide. The precipitated form is hydroxide, and precaution is that we will add NH4Cl before NH4OH, so less number of OH minus ions are formed. We cannot use NaOH instead of NH4OH because more number of OH minus ion will dissolve precipitate of aluminium and chromium. Another thing is that instead of NH4Cl we cannot use NH42SO4 or NH4NO3 because it can oxidize Mn plus 2 into Mn plus 3 and it can precipitate Ba plus 2 here.